Hello folks, welcome back to Learn Synthesis with VCV Rack. I'm your host, Dr. Lawrence W. Moore of the Wayfarer project. This is the beginning of Series 4 in the overall series Learn Synthesis with VCV Rack. And each one, 1, 2, 3, and 4 are basically like chapters in the book. So we're going to begin this chapter covering those synthesis concepts and techniques that have not been covered thus far in the series. For Series 3 and a little bit of Series 2, we were covering a lot of the community library modules, and we'll go back to doing that so people get to see what these different developers have made. But right now, I think it's good before we get too far along in the overall series to cover some of those synthesis concepts I haven't covered yet. So today we're going to look at sample and hold and how it works, and basically different things you can use it for. So without further ado, let's get to the content. Okay, so here we are. Simple layout here to start. Got the MIDI in. Got the VCV sequencer. We're mostly just going to use it for its clock and its ability to send out triggers on a clock pulse or clock tempo. Here's our sample and hold, which we'll be getting right to as soon as I finish the rest of the setup here. This is the Quantize module, which is great to use with sample and hold, so you can visualize what pitches are being generated and so forth. Well, you'll see as we go on. And I have an oscillator, so we'll be using sample and hold to generate pitches for this oscillator. And then we'll be using this envelope gate here basically to be able to turn on and off the sound. Basically, I'll press a key on the keyboard. I have the gate hooked up here, so basically when I press a key, we'll hear stuff, and when I release it, we won't. That way I don't have to keep adjusting the volume module over here. And this is a mixer. Eventually I'm going to add a second oscillator, so I went with the mixer. So the envelope is governing the mixer's level, and we have our one oscillator going into channel 1. We'll be adding a second shortly. So anyway, let's get to the sample and hold. There, get the whole module on screen. Okay, so the sample and hold has 8 slots. So you can see my mouse cursor here. 1, 2, 3, 4, 5, 6, 7, 8. These are inputs and these are outputs. An input is where you can store a CV value, control voltage value. It's basically we're modeling physical analog synthesis where that would actually be a voltage that you would send into here, and it would measure its amount with a capacitor or something like that. But since this is digital, we're really just sending numbers here. And so these numbers can then be used for other things, namely like the way we're going to use it today is for pitch. So the value gets stored in here. And we will, in a little bit, hook up the pitch here to the input here, and we'll fill this sample and hold with pitch values of our own determination. But just to get a feel for it, let's use it in its random mode, where basically it will put a random, each time we hit the push button, it will put a random value in this slot. And since there's nothing hooked up to its output, when I hit the push again, that value will basically go from its output to the next slot here. And when I hit the push button again, the first value that we generate, which would be here, and the second one that we generated, which would be here, would each move down another slot. So basically it's like moving down the slots. If there was an output cable hooked up, then it would go out the output rather than moving down to the next slot. But, you know, for a lot of the application you might want to use this for, you're selective about where you put your output cables. And in fact, what we're going to do is put an output cable here color code it yellow because that's what I like to use for CV. And hook it right up to the input up here. What will eventually happen is if I hit this push button 8 times, it'll generate a random value, cycle it down the next time I generate one, cycle it down the next time I generate one, until I hit it 8 times, it'll fill up all 8 of these. And then from that point on, if I hit push or send a trigger, and we'll actually use the trigger so we could basically let this bad boy run, we're basically going to hear the same 8 values because this output is now hooked up. So this value won't just go off into the ether. It'll come right back up here. And so the first random value that it generates will come back here, and each one in order will just be continuously cycling through. In other words, we created a loop. But we need to fill it up first of all with some random values. When you're doing the random thing, it's always good to right click and go down here to the random range and set a range that you would like. I'm going to put it on, I believe it's already on this, something narrow so we're not all over the place in pitch. Here we go, 0 volts to 1 volt. All right. So it will basically generate voltage values within that range. And that will translate later when we hook it up to the oscillator to pitch. So if you have something like 0 up to 10, you're covering a wide range of frequencies there. So you'll get a lot of really high beeps and a lot of really low things. I want to keep them within a range that would sound a little bit more musical. Okay, so now we just need to hit this. Since we have the random mode on, we just need to hit this push button 8 times. 1, 2, 3, 4, 5, 6, 7, 8. So now there are 8 random numbers loaded up in here. And what we're going to do next is take this output. The output can have multiple cables hooked up to it, all of these outputs, but the inputs cannot have multiple cables hooked up to them. Believe me, I tried. Basically, it can only receive voltage values from one source at a time. And right now, since we're using this as a loop, we can't hook up anything else to here. Otherwise, it wouldn't know which source to take a value from, I guess. But in any event, we can hook this output up here because then we want to take these voltage values, visualize them in our Quantize module here, and then we are going to take that output and feed our pitch input here on this oscillator. And I guess I got a square wave going into the mixer here, and the envelope is governing the mixer. It receives gates from our input, so our MIDI. So basically when I press a key on the keyboard, we hear things. But first of all, we got to send triggers to, let's zoom in again and hook that up. We got to send triggers from our sequencer to there. You could use anything that sends a trigger. And if you have like a clock generator that sends trigger outputs, you could use that because we're not going to use for this any of the other functions of the sequencer here other than having a trigger sent with each pulse of the tempo. So now we're going to run, and we are clicking away there, but I'm looking at this and I am not seeing values change. Let me hold down a key on the keyboard, see what we hear. Yep. So I need to troubleshoot. I must have done something wrong here. Yeah, we're hooked up trigger there. Are we hooked up to the trigger output here? Yeah, this is indeed the trigger output. And I can see the dots moving here. So yeah, it should be sending trigger pulses. Run is on. Is the tempo strange or something? Let's initialize sequencer. I was playing with it beforehand. Yeah, it looks like we only have one value in there. So I'm going to stop it. Anytime you're working with the sample and hold, and you're going to be putting things in, I think a safe thing to do is to kind of turn off trig here. Turn off random and initialize it again. Okay. Now we could put on random mode. Let's double check our range here. 0 to 1 volt. Yeah, that's what I want. Okay. You know what I'm going to do? I'm going to disconnect this. And then 1, 2, 3, 4, 5, 6, 7, 8. I leave my mistakes in just so we can learn from them. I think maybe I shouldn't have had that loop set up. What's this? Hold on. Dragging things all over the place here. Was that hooked up before? That certainly wouldn't have helped. Okay, so let's hook up our trigger. The trigger and the push button essentially do the same type of thing, except here a trigger source is basically pushing things along for you. But, you know, when you load them in, might as well just use the manual push button. So let's run. Now we're moving. Yeah, okay. So basically you don't want to have a loop hooked up when you're initially loading your values. That was the mistake there. So now we know for sure. I'm going to hold down a key, any key on the keyboard, to open the gate. Now, there's really 8 different values that were generated, but our quantize kind of helps put these voltages within slots that are, well, it basically quantizes them, like moving the voltage values to the nearest actual pitch value. So what probably happened is a number of values in our sequence were close to each other in voltage. And as a result, what we got was some, especially one after the other, that were kind of close in voltage, and then the quantizer moves them to the nearest pitch. But one thing that's cool about that, especially if you're doing random things like this, is it gives you a bit of a sense of like, you know, it's not a different note each beat. It's like it holds, you know, it gives you a sense of like a duration on some of them that's longer than the others. So I'm cool with that. I mean, it's all random anyway right now. But what we can do here is let's try doing this with a wider range. I think the result will be less values close to each other. Let's unhook our loop. And no trigger is being sent because the run is stopped, so I don't need to disconnect that. But what are we doing here? Let's initialize it again. I like to do that when I'm just clearing it or going to do things over again. Sorry, I need to zoom in. Like small print, initialize. There we go. And then what I'm going to do is turn on random and set the random range to something wider. I don't think I want it to be super wide. No. -5 up to +5. Oh, wait a minute. 0 to 3 volts or 0 to 5 volts? Yeah, let's try that. That way we shouldn't get any low pitches that aren't carried by the speaker or headphone, whichever you're using. Okay, so now we can hit this 8 times. 1, 2, 3, 4, 5, 6, 7, 8. Then we hook up our loop. here. Our trigger's hooked up. So we just turn this on. And our Quantize is moving around, so I'll hold a key. Okay, I released that because we got some dog pitches there. So yeah, I'm going to turn this down a little bit just to be friendly. Okay, so you get the idea. You could select wider ranges if you want. -5 up to 5 would give us a good across the frequency spectrum range. All right, so what I'd like to do next is just to show you that how the random, well, not the random, but the sequence kind of goes here. We have these 8 points, but we don't have to just loop all 8. I'm going to set up a second oscillator. Now, let me get rid of my extra zoom there. That should be enough space for another Quantize and another oscillator. Yeah. With room to spare. There we go. All right, so now we have a second oscillator here. Let's take our first one. And let's loop the first 4 together. And that'll go out to our first original oscillator here on the square wave. And then what I'm going to do is use a sine wave so we can hear the difference between the 2 oscillators on this one. We got its pitch hooked up. And we'll hook you up here to the output here and loop 5, 6, 7, 8 together. So it's 2 sets of 4. And what we'll basically be hearing are 2 pitch harmonies with each trigger. So whichever random values were stored in the first 4 and the last 4 at the time that I stopped running the sequencer and stopped the trigger, those 4 are going to be like in a continuous loop paired with one another. 1 paired with 5, 2 paired with 6, and so forth. You don't have to do things in parallel like that. I'm going to stop the sequencer. And what we're going to do is, let's say we're going to loop just maybe the top 3 and the bottom 5. So our outputs are hooked up right, and we have the bottom 5 hooked up with one another. Okay, so we can run it again, and I'll hold a key. Of course, I didn't play with tempo yet. Okay, so, you can do stuff like that. But still, we're talking random here. So what I'm going to do, stop the sequencer, turn off the random mode, and let's do this. We're going to go back to just one oscillator. Hold on here. Disconnect you. Yeah, you're not supposed to go there anyway. You go here. So we're going to do one oscillator for all 8, just like we did the beginning. But now what we're going to do, actually what I'm going to do is not have the loop hooked up and actually not have that hooked up either, because we're going to load values into these. And those values will be straight from my keyboard. Like that. Now what I'm going to press are some keys, and then I'll hit the push button as I hit the keys that I want to. One thing I am going to do temporarily, since we're only going to use one oscillator for this, I'll unhook the second one. And then I'm also going to unhook the gate here, because when I press a key on the keyboard, it would open the gate and we'll hear whatever pitch the oscillator's on. And I don't need that right now. We're loading things in, so you're not going to hear anything. I'm just going to tell you what I'm pressing. A D, an A, and D up the octave, down to C, down to B, down to A. Now I got to count 1, 2, 3, 4, 5, 6. And then I'm going to go up to the B again. And then the C will be our 8th one. All right. So I loaded them in. Now let's make sure they will loop. Why didn't that not work? Oh, this is already hooked up. Remember, I said that at the beginning. You can't have two sources hooked up to that input. All right, so we're looping. And we're taking our pitches here. Now, I just turned random mode off. One time before when I did that, I also forgot to turn random mode off, but when you load values in straight into the inlets, it'll take them and it'll override, the random generation. But I did turn it off. Might as well be thorough. Now let's hook up our gate. The envelope generator. And these are not going to be dog pitches, so we can put our volume back to unity. And okay, so let's run it. I see, yep, pitches coming in here, the D, A, D, and then here it's like going down and back to D. All right, sounds good. So you have an offset dial there, but we're going to see in a bit another thing you can do if you want to be able to change basically what pitches you're on. It'll maintain the intervallic relationships, but yeah, actually might as well do that now, because now that I've played this, all right, we see that. Now let's take the output from Quantize and put it into the FM input here. We're not going to really be doing frequency modulation, but it's going to basically result in being a pitch offset. And we're going to hook up our pitch to the oscillator. Now when I press a key on the keyboard, and especially if I turn this dial up here on FM, when I press a key on the keyboard, we're going to hear these notes proportionately shift according to what key I press. Maybe a little too low for So we kind of have like an arpeggiator. Not as many features as as you might want to have in a arpeggiator, but you know, for trying things out, you can get some cool stuff. Let's stop the sequence and let's do our second oscillator again. Hook that up to input 2. We're going to hook you up to the second quantize. Well, oh. Just move this over, actually. Or we could have this stay on the same pitches that are in here, and this oscillator will move, but the other one won't. So let's see what happens with that. Let's do, oh boy, we'll do 4 and 4. Okay. Now you are going to be on these first 4. Now it's going to do whatever the current position of the different pitches are right now. And it's probably not in order of the sequence that I set, but that's okay. And you are going to receive 5, 6, 7, 8. Or is that already going out to, nope, it's only going into this loop. Okay, good. Here we go. Let's see what happens. Did a little pitch shift there at the end. All right, so there you see, you can, when you're fooling around just looking for different things to do, you can do a bunch of things with it. One other thing that we can do here is have this reset whenever I press a key. And what that means is it goes back to square one here each time I press a key. It's not that that in and of itself is absolutely necessary. Oh, and to make sure it works right, we better make sure this is on monophonic. Yeah, it is. Basically, what it'll mean is each time I press a note, it's like a trigger happens, and whatever position they're in, it'll at least be the start of that. So in other words, it'll be more like in line with tempo. So cool stuff there. So anyway, I think from this you'll have a good idea of what sample and hold does, and its little quirks. You know, don't have the loop hooked up when you're pushing values through. And anyway, it should give you something to play with, to have a little bit of enjoyment. If you found this useful, helpful in any way, please hit that like button. Leave a comment. Let me know what you think, or if you found this useful at all. If you would like to use sample and hold or come up with some ideas for uses for it, please let me know. Yeah, basically it's 8 cycling CV values that you can use, or in pairs or in 3s and 5s, whichever kind of designation you want to do. Maybe 2 and 6, you know, and see what happens. All right, well, until next time, take care and stay free.